Okay, good, good. But for chemistry, you also see cubic centimeters. And there is one more. Okay, I show you. Because this one is new. These are the three you will see. 1, 2, and 3. Okay, tell me, 1 cubic meter is how many cubic centimeters? You can feel free to work out. Good. Okay, this one is new. Have you seen this before? DM cube.
No.
No,
I know what it means.
Okay, you are going to see this for the rest of upper sec. Okay, I write down what it means first. It stands for decimeter. Or cubic decimeter. Now, for chemistry, it's always dm cube. But you must also, it's good to know what is 1 dm. Basically, 1 dm is 10 cm. Yeah. Okay, or of course, it means 100 mm. And what I want you to know, especially, is this one. 1 dm cube is 1000 cm cube. This one you must know. Okay, by the way, have you heard about letters? Letters L. Should have, right, primary school?
Yeah. Yes.
So if you notice, one letter is actually 1 dm cube. And by the way, just to help you with your understanding, if I cube this, I also cube this. So what do I get? 10 times 10 times 10.
1000.
Yep. Okay, so that's how I got this. Okay. All right, so the mix up on it is definitely coming out. dm cube. Not dm, but dm cube.
Okay.
Okay. How do I measure volume? It depends on whether it's liquid or gas. All right, to measure volume. Come tell me, liquid, what are the ways you know?
So measuring cylinder, that's yeah. One go fast.
Yeah, there is. Have you seen the words burette and pipette? Burette, pipette.
Yeah.
Those will definitely come out, even for your practical. Oh, by the way, you know there's a practical exam.
Yeah.
There is. Okay. Right, so these are the ones I want you to take note of. Tell me what is this?
Huh?
This one.
This I don't know the difference.
Okay, you better know by now.
Okay.
Feedback.
Okay, that's what you got.
This is a feedback. Okay, I can take a look, but just be careful.
Okay.
You see the marking here?
Yeah.
So if your liquid gets sucked up all the way to this mark, is 50 mils or 50 cubic centimeters.
Oh. Okay.
Okay.
Yeah.
This is of course smaller one. Note the volume.
It's 10 ml.
Yeah. Okay. So
Okay.
for DM feedback, try to remember because in your practical exam they ask you to use this pipette to measure, let's say 20 ml. So you're supposed to be able to pick the right one. Okay, now take note. Do you write this part fixed volume?
Yeah.
Okay, so it's fixed. You have to suck up to that mark there. Same thing. Can you see the mark?
Yeah.
Okay. So fixed volume. Now, I didn't tell you the range. What's the range? Of course, it cannot be too big, right? It's only about this size. So I type it out for you. You just write down 2. I don't have it. I haven't written it down. So it's about 1 to 100 cm. Okay. These are the typical sizes. So why is this important? Because if the question wants you to measure a volume of, let's say, 500 cm3, you cannot use a pipette.
Oh. Yeah. Yeah, I see.
Okay, I won't say you totally cannot, because in real life, you know what you do? You do it 5 times.
Oh.
But for exam, you cannot.
Okay.
Remember this guy?
You.
Yep. What's the volume? What's the volume range?
25.
Okay. So
Okay.
that means I mean, I'll roughly tell you how it works, but eventually you have to do it in the practical. I think your school will arrange some practical sessions, usually holidays time.
Yeah, I think so.
You know what this is?
I don't know what it's used for.
Okay, this is a valve. 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 Oh, I didn't write it there. But what's important is, let's say what I'll do is normally I close this close, this open. So that means whatever I pour in from the top, if it's open, it will just keep on.
Yeah.
So I close it first. I pour in from the top. Here, probably somewhere here. And then I open this, let it drip until it drips to this 0 mark.
Oh.
Then I stop. Close it. Then for your practical, it will tell you to measure, let's say, 10 cubic centimeters of liquid. So what I do is, let's say you have a beaker here. I hold it over the beaker. Remember, it's at 0 now, right? 0. So I open this and it will slowly drip down until the 10 mark. Then I quickly stop. So that means in the beaker, you have 10 ml of liquid. Okay, that's how it works. Can you remember?
Yeah. Okay.
What else I need to tell you? Look at the marking. What's the smallest marking? Smallest interval?
0.1.
Okay, it's 0.1. So remember that.
Okay.
But
same as the feedback, right?
theoretically, yes.
Okay.
Let me see. Do I need to tell you more? Okay, not for now. That's why I wrote down there 0.1. I mean, I'm just following the O-level syllabus because in real life, it's a bit different, slightly different.
Yeah.
Okay, one last thing. For burette, this one is 25 ml, right?
Yeah.
There's a bigger version, 50.
50.
Yeah, there's a much longer one, 50. But most labs don't have them. Usually it's 25. So, but I want you to write down maximum up to 50. So again, same idea. If your question wants you to measure something more than 50, you cannot use it. Can. Gas fringe, have you seen it before?
No.
Okay, I don't have it to show you, but it looks something like this here. Actually, it's no big deal, no. It just looks like normal string. This one.
Oh.
Yeah, it just looks like normal string. Just that. Okay, let me just draw here. So what happens is you allow the gas to enter here. Then of course this plunger will slowly move upwards. And of course you record the volume here. But good news, I've never seen it being tested in the practical section.
Okay.
However, you need to be able to draw this. You need to draw it out. Draw it out. They can ask you to draw for the theory part. But of course, be very mindful. The strings can be also horizontal. You can also place it horizontal. And keep that in mind. Okay. Now, what is... Oh, one last thing. You notice the size is not very big. It's usually about this size, 50 to 100.
50 to 100.
Yeah, it can't measure very huge volume of gases.
Okay.
Okay, this one here. Okay, lovely temperature.
Kelvin.
Yes, but chemistry didn't use it.
Chemistry the.
Yeah, they still use degrees Celsius. What's the SI unit? Temperature.
Kelvin.
Yeah, but like I say, you won't see it in chemistry, so yeah, doesn't matter. This too, no problem. Have you seen this before? Temperature sensor?
No.
No. I don't have an actual sensor by some.
Oh, okay.
This is not designed to measure temperature, it's designed to measure water conductivity. But because temperature is so common, it's incorporated into it. So if I just turn it on, sorry, the battery is running on.
Okay.
You can't see much. But essentially, if you turn it on, it will show the temperature too, in addition to water conductivity.
Okay.
So normally we dip it into the water and then test the conductivity. But you won't do it for chemistry. It's not for O levels. Okay. Okay. Anyway, temperature sensor is a very small thingy. Let me see. You see I can't tell exactly which one it is, but the black color tips.
The conductivity.
Conductivity will be the two metal circles. Temperature should be the black color tips.
Okay.
So it's actually a very small device. Okay, come. Gases. We've got to know a few gases. 1, 2, 3, 4. These 4 are odorless and colorless. Okay. What's meant by odorless?
There's no smell.
Okay. Then you have a few more. 4 pungent gases. 1, 2, 3, 4. Oh, by the way, because this Miro board doesn't allow me to do subscript, make sure you write with the subscript. That means like that. Same thing for all the N2O2 and so on. By the way, do you know what is the first one? NH3. There's a name for it. No, that one is CH4. This one you have to know. Ammonium. And how does it smell like? You never smelled before? I'm sure you have. Because it's the urine smell. Yeah. But for your exam, don't write urine smell. Don't describe it as urine smell. You describe it as pungent. This is the answer you should use. Okay, SO2. What's the full name?
Sulfur dioxide.
Good. Cl2? Okay, or chlorine gas. This one.
Hydrochloric acid.
This one is tricky. You better note down. It's very tricky. Yeah, not wrong, but the thing is this. The name is called hydrogen chloride. Yes. So it's a gas, of course. but it can dissolve in water easily. Once you have water, it will turn into hydrochloric acid. Okay, so this one, be very careful. I've seen this kind of question coming up many times. If it's pure, it's a gas. But if there's water, then it will turn into your acid.
If this question come out, I just put chloride gas.
Of course, you have to look at the whole question carefully. Are they referring to an acid? Then if not, it's just a hydrogen chloride gas.
Okay.
Take note of the color for chlorine. Now, this is how it smells like, swimming pool. Because they use chlorine in swimming pool. And but like I said, in your exam, don't write swimming pool smell. You still describe it as pungent.
Pungent means it's not a nice.
Yeah, very strong smelling, irritating usually. Okay, same thing for this. Describe as pungent. And take note, the four of them tend to react with water. This is important later on. So take note, 1, 2, 3, 4. Okay, so just a few more points about the earlier ones. Okay, remember this number.
Yeah.
You can, that means for nitrogen is 78. You add the two together. Yes, good. So there's still 1% of other things. Can you remember what are the other things?
Carbon dioxide and water. Other gases.
Okay, never mind. That one we'll come to it later on. But yeah, you're basically right. Okay, that.
Yeah.
You didn't tell me what's combustion.
Combustion is burning and oxygen.
Good. Remember that. Confirm coming out.
Okay.
Confirm 100%. Have you done this before?
I did fermented spleen.
Okay, lighted spleen. What happened to the lighted spleen?
Extinguished with a pop sound.
That is for hydrogen. Come, this one.
Yeah.
But for oxygen, notice the difference in the word. And this is lighted. But what's the difference?
What?
Difference between the two words.
I don't know.
Of course, it's important. You cannot put the wrong word. Lighter is very simple. It means there is a flame. Okay, glowing means there is a the orange light. You see the orange light at the end?
Yeah.
But yes. So of course you don't use the words flame or orange light. So use the proper terms, glowing versus lighted.
Okay.
Okay, so this one you're right. Extinguish your pop sound. That is the model answer. This is the model answer for oxygen.
Then we go to like what are the reference for this distribution? Okay, so let's start this question. Is this person? X pencils. Let's start with that. Then we actually distribute the pencils amongst 40 students. How many pencils did each student receive?
Now, again, just a note, rekindles means it bursts back into a flame.
So it becomes lighter.
Yeah.
And all
Yeah.
these transfers cost.
And by the way, you may have to do this for your practical exam as well.
I did.
Did you do for oxygen? No, right? You said okay.
I got hydrogen.
CO2, do you try it?
Yeah.
How do you do it? Blow it using your breath. Do you see the cloudiness?
Yeah, I did.
Does your school allow you to write cloudiness?
Form white juice.
Okay. Okay, so again, this is the model answer. All right. So I mean, some schools allow cloudiness, but most schools don't. By the way, what is lime water? Lime water.
Lime water.
Don't tell me lime juice.
I don't know how to say.
Oh, okay. How does it look like?
It just looks like lime water.
Okay, fair enough. First thing, don't confuse lime water with lime juice. It doesn't come from fruits. Right now, this one will confirm come out. This is actually calcium hydroxide solution. Does your logo set cover those chemical formulas?
Chemical formula.
Like water is H2O.
Yeah.
Calcium hydroxide?
Calcium hydroxide. No.
No, right. Okay, right now. This is the formula. Yes, there's two brackets, of course. Okay, of course, we'll cover this sometime in the future, but just note down for now.
Okay.
Let me see, just a small note, even though I haven't seen it being tested before, CO2 is about 0.3%, 0.03%. But now we are reaching about 0.04 already because of climate, the release of CO2 in the air. Okay, let me see, anything else I need to tell you? This one, do you write down this part? Yes, right?
Yeah.
Okay, I hope you realize what that means. It means it's hazardous. And sometimes they have a question that tells you this is produced, and by right, it means you cannot do it in the lab.
You can't do it in there.
Okay, let me maybe qualify that. Small quantity still okay, like the pop sound still okay.
Oh,
But if let's say, I think it depends on the questions. Some questions will tell you they want to do this particular experiment, but anytime you see H2, you may want to assume that huge quantities are produced. So that is a big hazard. By right, you can't do it in the lab. Just keep this in mind. Keep this in mind. Okay, let me see. What is it?
That means with times.
Oh, so far, questions? Fine. Okay, last part. Oh, just take the last part.
um,
So it's 3 times. You take 2n times 3.
Notice the difference, huh? Just now I talked about gas strange. Gas strange is to do what?
measure gas.
You see the difference in the word, measurement of volume versus collection. This one I only want to collect it. I do not need to measure it.
No need measure.
I don't need to know how much, what's the volume I collect. But if the question ever say measure volume, only one thing to use, gas range.
Gas range is the only thing that can measure gas.
I mean for O levels, of course. But if they use the word collection of gases, you can use these few methods here, or you can also use gas range. Take note, gas range can also collect gases. But what is the disadvantage of gas range? Just now I mentioned a bit, but I didn't use the word disadvantage.
Collect more.
Yeah, it can only collect small volumes. So keep that in mind. Okay, so well, for this real collection methods, it depends on first thing. Does the gas react with water? Or does the gas dissolve in water?
They're all different methods, right? X plus Y plus Z. So then it's definitely one for this. As long as they're different methods, you can put them in separate numbers, but if they are the same, so if I say like X and I add the X, they'll be plus QX plus Y plus Z. Okay, but in this case, no. It's fine.
So that's the first question to ask. So if there's no reaction with water, then you use this method, displacement of water. Whereas if there's a reaction, then you use displacement of air. But that's not the end. Okay, let's just quickly show you how does it look like. It looks something like this, very simple. There is a tube going down, then going up again. Glass tube, of course. You have a basin here. And then there is a cylinder here. Usually glass. And then you fill it with water. Okay, Dylan, the important thing is this, your tube must be underwater.
Touch the surface.
No, try not to. Try not to. Because you want your gas to go through the water. That is the important thing. So, of course, your gas will get collected here.
So why are we taking out the negative side? Putting it in. So -1 times 5 will be divided by 5. And if positive 12 times -1 will give me -12. So it's a bit blurry, yeah. Okay.
Yeah.
You draw that.
Yeah, do that.
Okay. Again, they can ask you to draw this. That's why I want you to draw. So remember, displacement of water is the name. Now, normally, what gases do we use for this method? This few.
Oh, yours is insoluble.
Yeah. What else do you remember about these four gases? They are all yes. You notice they happen, just happen to be all of them are odorless. So there's one way to help you remember. If these four odorless gases can be collected by water displacement. But Dylan, no need to write down. However, I want you to know, I won't say they're totally insoluble. Obviously, oxygen can still dissolve in water.
Yeah.
Okay, otherwise, your aquatic life, you will all die out. Okay, so just take note of that relativity then. Okay, next, for the rest. Okay, for the rest, you have two possibilities for displacement of air. There are two different methods, and it depends on density of the gas compared to air. All right.
So I think a lot of people have one. I don't know why you got that. I'm thinking it's because you added up these figures, right? Yeah. So that would be. I think in this case, try not to move it to the end. You just go like 6 times 3%.
So for outward delivery, it's very simple. Again, you have a glass tube. The key is pointing out, and then you have an inverted cylinder. Because it's quite light, so the gases will float to the top. Okay, and the air get pushed downwards. Very simple, very simple. And you probably can draw the same. What is the apparatus for downward delivery? How does it look like, downward delivery? Yep. Just a small note lah. In real life, if I do this, I put this tube as high as possible. It depends on your tube lah. You can't control that. That one is depending on your lab, what kind of apparatus they have. But I'll put it as high to the top as possible. Same thing, put the tube as low as possible in real life.
Yeah.
So of course the gases you sink to the bottom. I think you can visualize that.
Yeah.
Whereas the gas here will be floating right at the top. But density of gas, do you know anything about density of gases?
See the density with
Okay. Let's step back. Basically, density of solid will be the highest. Solid greater than liquid, greater than gas. Okay, in general, that is true. But now we are talking about individual gases, no? They also have their own different densities. That the tricky part how do you remember which one is which? But for now, just take note of this few first. Now, for your lower set, have you learned something about core molecular mass or molecular weight?
Not yet.
Not yet. But you've seen the periodic table, right?
Yeah.
Okay, teach you something first, even though they don't teach this so early normally.
Okay.
Okay, come. Look at NH3. It's 1 nitrogen and 3 hydrogen, correct? What's the mass number for nitrogen?
What's number one? How's something
Good. Hydrogen? Good. So 14 plus 3 times 1, that would give me 17. And the name is molecular mass. Of course, normally they add the word in relative in front as well. There's a short form, and take note of this short form. It's going to come up sooner or later. Capital M, small r. They call it MR. Relative molecular mass. Okay, come Dylan, very simple. I want you to calculate the MR for these three guys.
Oh.
Got it? Cl2?
71.
Good. HCl?
36.5.
Okay. And SO2?
64.
Good. Okay, that's important thing about it. Now, air is a mixture. Okay, you remember that, right? Air is a mixture, but we can also designate a MR for that. Okay, this one no need to know for O levels. However, it's very useful. The MR is 29. And you notice something, right? This is less than 29. All right. Less than 29. So that means it is lighter than air.
Less than.
Yes, less dense than air. And you notice all these are greater than 29. So therefore, they are denser than air. That is a very useful method to figure out the densities.
Okay.
Can I?
Yeah.
You know what will happen? There are questions occasionally that ask you to look at these four gases. Okay, question for you. Can I use displacement of air to collect these four gases?
So and
Why?
what's not so long.
Uh-huh. Okay, and so never mind, no need to think. The answer is actually yes. But it's preferable to use water, displacement of water, because you can see it very clearly. They are collected there. Because if you just use a upward or downward delivery, there's no water, right? So, and all these are colorless as well. So you can't really see anything at all. So people, for this core, they prefer to use this method.
Oh,
But you can also use this too. Can
how
if
does
necessary.
it harder?
I wouldn't, I mean, let's say you don't have the right equipment, then yeah, I'll use this too. But my question, okay, I want you to work out which is using upward and which using downward.
Only
Yeah, for the four of them. Which one can be, if let's say I decide to use displacement of air, which is supposed to be using upward delivery and which ones are using downward delivery?
hydrogen will start moving.
Good.
Nitrogen is also upward,
Mm-hmm.
while oxygen and carbon dioxide is downward.
Oxygen and carbon dioxide is downward. Okay, come. What's the MR for N2? 28. How does that compare to air?
It's lesser.
Yeah, it's less, but there's a problem here, because they are very close. So technically speaking, this will not be a very good method. Technically speaking, all right, for N2, so take note. But yeah, right, this one is upward.
What's that analysis between?
Yes, the difference is very drastic.
Yeah,
O2, MR,
32.
okay. So at least this one is pretty, I think the difference is more significant, but of course, if I have the choice, I would still rather not use it because it's again still quite close to 29. CO2,
44.
good. So for this one, downward. Okay, Ethan, can follow.
Okay.
Good. Last part of theory for today. Okay, after you collect your gases, they want you to dry your gases. That means remove water, especially for this one. Remember, you allow your gas to go through water. Some of the water vapor you collect here as well. Okay, so you have to dry the gas. How to dry? Okay, here. 3 methods. There are 3 drying agents, 1, 2, and 3. Oh, by the way, con here stands for concentrated. Sulfuric acid, know the formula as well. Oh, I've written here, this one, H2SO4, but I write it up with the subscripts.
The amount that she's with is any part we're confused about.
Okay, so sulfuric acid is of course an acid. Therefore, you cannot use it to dry an alkaline gas. Okay, fortunately, I haven't mentioned that part yet. You know, some gases are acidic, some are alkaline. Yeah, of course you don't. Yeah, but that's all right. That's all right. You learn along the way. Okay, where's my whole list of gases? Here, right? Okay. This theory will only come in much later in the year, but this one is acidic. It's an acidic gas. Because, okay, very simple. If you allow it to dissolve in water, it will impart some acidic properties to the water.
Carbonic acid.
Okay, good. Good that you know that. Okay, that's why CO2 is an acidic gas. 1, 2, and 3 are neutral. Okay. How about this few? Obviously, this is acidic. Obviously, because it turns into acid. This one? No, it's acidic too. We will produce an acid. This one, acidic. Because you've heard of acid rain, right?
Yeah.
It's due to this gas in the air, no? SO2. It's given out by burning combustion factories. So when the rain comes down, it will dissolve this in the water and form an acid rain. This one, alkaline gas. Okay, come Dylan, come.
It's like that's actually like not university. Like you can try something else. Something try. So yeah, I think like this week we should usually run through it. Yeah. Yes.
Count how many acidic gases are there?
There's 4
Good.
acidic gases.
Neutral?
Neutral is 3.
Good. Alkaline?
There's 1.
Yep. Try to remember that.
Okay.
Try. I mean, maybe it's a bit too much for now, but
Gas.
is this one?
All these are only gases that are.
Well, of course not, but these are the 8 most common gases you will see.
Okay.
There are others as well, like what you said, methane. Methane is going to come out too, by the way. Just that for info, methane is insoluble in water, it's odorless, it's colorless, it's not as it's neutral.
Okay.
There are many other gases, but these are the standard ones. Okay, what else? Oh yeah, drying agents. So yeah. So sulfuric acid is of course an acid.
Yeah.
So I cannot use it to dry an alkaline gas. Therefore, I cannot use it to dry ammonia. Okay, makes sense, huh?
Yeah.
Because they will react. What's the reaction between acid and alkaline?
In form of salt.
Name of the reaction?
Name of the reaction.
Acid plus alkaline produce salt and water. So the reaction is called?
Number.
Have you heard of neutralization?
Oh yeah.
Okay, don't forget. Let's write down too. Okay, this is calcium chloride is a salt, but more importantly, is a neutral salt. So it doesn't react with most gases. Therefore, you can use it to dry most gases. Okay?
Yeah.
But just a question, even though they have never asked this, what is fuse? Have you come across this word fuse?
No.
Fuse means melted and then allowed to solidify. Okay, but I don't think I want to elaborate too much because they won't ask about this word fuse. Okay. But basically, if you do not know what to use, this one will work most of the time to dry almost any gas. This one, quick line, is CaO. There's another name for CaO. Make sure you know it. Calcium oxide.
That's
And what else do you need to know about it? This, have you come across the word base or basic? No, no. Okay, never mind. I just use the common name, alkaline compound. Okay, so therefore you cannot use it to dry acidic gases.
Yeah.
And most of the time, you only use it to dry ammonia, which is alkaline, by the way. Yeah.
Yeah.
Okay, but how does it look like? Last thing already. I didn't draw it out. Let me show you the where is it? Have you bought your textbook?
Section.
Okay, haven't read yet, right?
No.
No, it's okay. But just curious. In your textbook, you probably see something like this. This one is for corn acid. Hold on, let me just wait for the connection. Okay, so this is the setup. Now, the setup is not standard. It can also look like this. I can also use a conical flask. But the important thing is this. This is important. Gas goes in here. So remember let's say I have N2. Okay, N2 gas. You pump it into here. The important thing is this entrance is under the acid. But notice the exit is above the acid. That is the important thing. Because my setup may not look like this. My setup may look something like this. But of course, I need a stopper here as well, stopper at the top. But essentially, your gas goes under the acid and it escapes above the acid. How about this? This tool, again, you don't really have to remember how it doesn't need to look like this, no? The thing is, I redraw this. The thing is, I hope you realize, obviously acid is a liquid.
Yeah.
This one is a solid. Quicklime, and this one, calcium chloride, is a solid too. So what I do is, I force the air to go through the solid.
And the air getting filtered.
Yes, good. That is the point. Same thing here. I mean, it doesn't have to be a U-shaped tube, no? I can also interchange between these two. I mean, I can put my calcium chloride here. I can put my calcium oxide here. It doesn't matter. The shape doesn't matter. The whole chunk acts as a filter.
Only the gases need to go through the agents, right?
Yes, that is the important thing. And for a liquid agent, make sure it goes in under the liquid, escape above the liquid. Okay, whereas for this, I can also give you another setup, no? My setup can look like this. Hold on, now let me draw it up for you. I can just have a cylinder, and then I pack all my solid here. Let's say calcium chloride. I pack it here. I mean, I have a stopper here as well. Stopper. Then I just compress my gas from left and the exit from the right. This will work as well. No? Okay, so just keep these principles in mind. So see what you want to write down for this few methods. Anyway, this diagram is in your textbook if you are using chemistry methods. Okay, any questions?
No.
No, huh? All right. I think you should be able to do very well, but you just have to ask if there are any questions. Okay, tell you what, I'll pass this to you. Right. You got some time, so let's see how many you can do.
Oh.
Class is. I think class is. So. We will try to finish up our communications. Then I'll go through what we've done, and we can pick the rest of the. Okay, so just keep doing this. It's something like that.
What does it mean by copy the diagram through here?
Oh, okay. Because you need to copy this, but you also need to add in extra equipment.
Oh,
Sometimes in the exam, you see this kind of questions. You need, of course, because they don't allow you to write on the exam paper itself, the question paper, you have to copy this onto your answer paper and then add in extra equipment.
okay.
Special ratio. First, 6, 5, okay, now we are to that. Aaron has 18 right. Okay, so is there anything you see common? 18 is 6 times 3, so we can essentially do this. Then here I think I said the only difference reason that this is line, so it needs to be so that is in line.
Dylan, maybe you call for a while. Let's go through at least some of the earlier questions to make sure you're on the right track. Right, A, true or false? Okay, good. But of course, if you are guessing, you better check with me. If you are not sure or anything. True, false? Why?
Because how you read this is
Mm.
you read it at the bottom, the
Right.
middle of the line,
Mm.
and it says 13.6.
Okay, good. Okay, good. Make sure you can read it. B?
False.
Why?
Not all gases can be collected. Like some that is not soluble in water.
Some that are soluble in water or react with water
Yeah,
cannot be
cannot be
using this method. Okay.
Yeah.
Okay. D?
false.
Why?
Because concentrated sulfuric acid would react with the ammonia gas.
Okay, good, excellent. Make sure you remember that. So, well, of course, please mark your own answers. MCQ number 1?
B.
Good.
Put D for concentrated.
Okay, you know why? There's a trick there, very tricky. Now, look at your pipette. These are your pipettes.
Yeah.
50, 10. There is no pipette with 10.5, 10.2.
Oh,
Okay, it's always a whole number for pipettes. 1, 2, 3, 5, 10, 15, 20, 25, 30 is very rare. 50, 75, 100. you won't see a point something for pipette. So note that down.
So water level increase becomes water.
Okay, one other thing, make sure you notice this word accurately. That means you cannot use beaker. You cannot use conical flask.
Yeah.
Okay, let's go on. This one, X and Y. What can you infer about gas X?
That is denser than Y.
Denser than Y. Okay. So that will be C. Good. Okay, number 4, which separator should he use?
Or A.
Good. Okay, this one, let me just, number 1, let's quickly go through. 80 cubic centimeters.
Actually, centimeter bigger.
Bigger.
I got one, so I also a cylinder.
Cylinder. But between the two, which one will you choose?
Which one I choose?
Yeah.
I think I'll choose measuring cylinder.
Okay, why?
Because measuring cylinder is for measuring.
Okay, so for your answer in the exam, measuring cylinder is for measuring.
I thought there's two answers.
Not for this case. Okay, maybe you write down first. Because for beaker, it's not actually used for measuring, no.
Is it used for just storing liquid?
Yeah, storing, holding. Okay, I don't know whether you noticed this word there. I hope you did. Do you notice measuring, holding? It can be quite tricky.
Okay.
But can I use a burette
Correct.
for part A?
Yeah. Because the burette can only contain 50 cubics.
Yes. Yes. Okay, remember that. Part B, hydrogen.
50 cubics. Gas rich.
Okay, nothing much to elaborate on. Part C.
50 cubic centimeter burette.
Okay, good. You notice the 0.10. Look out for that. Must use burette. This one, boiling.
Boiling.
Boiling tube. Okay, this is a bit tricky. Have you seen the boiling tube in the lab before?
Yeah.
How big is it?
Not very big.
Yeah, it's not very big. About 10, 20, at most maybe 25. That's the tricky part. Maybe you note down somewhere. Boiling tubes are not big. So what should you use then?
Boiling.
This one is a trick question. They use the word boiling to trick you. However, you can also use a beaker for boiling.
Beaker.
Okay. Or conical flask, but there's no conical flask here. Part E.
I put watch glass. I don't know what it does.
Oh, yeah, I've seen it before. It's quite small though. It's just about this size of your palm. It's just a glass. I mean, like what you see there, just a concave glass. And yeah, basically it's for solids. So yeah, correct. It's quite small, but here 2 grams is good enough. Last one, 5 cubic centimeters of water.
Boiling tube.
Yep. You just need to hold. You don't need to measure, and you need to heat anyway. So might as well use the boiling tube.
Yeah.
I think just look out for all those tricks lah. Usually it's quite straightforward. Just don't get tricked. Now, Tell you what, if you're still coming next week, bring this paper along. Okay, so just let your mom know, but then you
Why you
continue.
complete?
Complete it. Okay, if you have the time, you must well complete it. Mm. Okay, any final questions for today? No, just a note in case you're going home to do number section C. I want you to identify these three things.
I think I'll just finish question 2.
Okay, fine. Then I'll remind you for the last question 1 next week then.
Okay.
Okay, final questions? No, okay, good. Bring along this if you're still coming back.
Okay.
How's your feeling? Everything all right? Are you printing for the coverer? You are, right?
Sorry?
Are you printing the
printed
materials?
already.
Oh, printed already.
Yes, I am.
But send me the instructions as well, so that I can convey. Oh,
Yeah. Okay.
answers are there answers around?
No, it doesn't show answers.
But you have your soft copy answers, right? Do you?
Not yet.
Not yet. Okay.
Maybe it didn't.
Yeah, it'd be good to have the answers as well.
Okay, sure.
I mean, basically it's for the coverer to refer to.
Okay, sure. Thank you.
Okay, welcome. Okay, yeah. See you, Dylan. Yeah, sure. Remember them. If you are coming back, I'll ask you which is which.
Okay. Bye.
Bye.